Okay, so example 5, Carly and Daniel finishes their final act in the LHS musical by dancing off the stage with the spotlight covering their every move. If they're moving along a straight path at a speed of 4 feet per second and the spotlight is 20 feet away from this path, what rate is the spotlight rotating when they're 15 feet from the point on the path closest to the spotlight? Okay, so I think to kind of organize our thinking, we need to do a little bit of a drawing. So here we have the stage, and the spotlight is over here, shining onto the stage, right? So we have this whole stage, and imagine that here's Carly and Daniel performing, and they're like going off stage in that direction here. Let's say they're moving off stage in that direction. The spotlight closest, where the spotlight is closest, it's a point away from a line. So remember, that's a perpendicular distance. So you're told that that spotlight is from this path. What is the rate of the spotlight rotating when they are 15 feet from the point closest to? So the spotlight is 20 feet. That's not moving, okay? It's just going to rotate. And then the spotlight is then going to start tracking their every move in that direction. So it's going to sweep out some angle there, like that. So things that are not moving is the 20 feet because the spotlight is positioned where it's positioned, but their movement, let's call that X, that's changing, and the angle is changing. Those are the pieces that are changing, I think. If they're moving along a straight path at a speed of, okay, so their speed is dx dt, or whatever variable you chose there for their distance traveling, right? Is going to be 4 feet per second. Okay, I'm just going to put this off to the side here because that's something I'll need later, but I don't actually need it in the beginning. Whoops. Let me try that again. Oh, it won't let me do it. Come on, I want to pick all of it. There we go. All right, let's move you down. We'll need you later. But just so I have my thoughts organized. Whoops. Like that. So then it has, if they're moving along a straight path and the spotlight is 20 feet away from the path. Okay, so that's where we get the 20 feet from. What rate is the spotlight rotating? Okay, so I want to find d theta dt, because that's an angle when we're talking rotating, when they're 15 feet from the point. Okay, the 15 feet is an instant. All right, so then I have to find a way to relate theta to 20 to x. And the only way I can get an angle in a right triangle to relate to the sides is to use trig. So I'm going to use tangent of theta is equal to opposite, which is x, over 20. And then we're going to take the derivative with respect to time because I have the equation and we're ready to go. D dt tangent of theta and d dt of 1 over 20 times x, like that. So on the left-hand side, we know that the derivative of tangent is secant squared theta. Don't forget, d theta dt is equal to 1 over 20 times dx dt, like so. And then now we're ready because we have the equation. So then we're going to say, okay, we want to know when x is equal to 15. What's happening, right? So I'm going to draw a right triangle. This is 20, this is 15, and this is my theta right there. Well, if I know that, I know I have to find secant squared. I'm going to need to know the hypotenuse. And so I'm going to have to use Pythagorean theorem to find the hypotenuse. I was trying to be nice. This is, I think it's a 3, 4, 5 triangle. Yeah. So this would be 25, but you would use Pythagorean theorem to do it. You would do 15 squared plus 20 squared is equal to whatever this is. Let's call that like z. So z squared, right? So that's going to give me 25. If you can do it and see that it's a 3, 4, 5 triangle, awesome. So z is equal to 25, let's say, like that. And I know that dx dt is equal to 4, and it's positive 4 because they're lengthening the segment x, right? All right, so I think we're ready because we want to know secant squared theta of d theta dt. But look, just a little aside here. Secant is the reciprocal, so I can actually find secant of theta, is the reciprocal of cosine, and cosine is adjacent over hypotenuse, so that would be 20 over 25, but secant would then be the reciprocal of that, so that would be 25 over 20, which reduces to 5 over 4. So that means then secant squared would be 5 over 4 squared d theta dt is equal to 1 over 20 dx dt, which I'm given is 4. So then solving for d theta dt is equal to, all right, what do I get? 1/5 there. So then it would end up with like 16 over 125, I think, right? We get 4 over 20 is 1/5, and then multiply by the reciprocal of 25 over 16. Yeah, that seems about right. Now the question is, what are the units? It's always going to be radians per, when it's asking for revolution or theta. For this, it's always going to be radians per, and then what is the units here we're doing for time? Seconds. And we'll discuss in a little bit why that is the case. It's an interesting question why we always use radians in calculus, and I'll address that in the next video. So here, the rate at which the spotlight is rotating is 16 over 125 radians per second when Carly, oh, I forgot the E, sorry, Carly, and Daniel are 15 feet from point on path closest to the spotlight. And that's example 5 with some trig. Doesn't make it much harder though.